So good afternoon, good morning, good evening. Welcome to EIG's 23rd webinar, Leveraging Digital Twins to Accelerate Industry 4.0. This is the first of a series of webinars on leveraging digital twins and bringing visibility to your COGS. Implementing digitization in a streamlined manner is one of the greatest challenges that we face today. With companies' limited resources, speed to implementation of digital transformation has always been a challenge. With limited resources, it makes it even more difficult. So what we're going to look at is how can we use digital twins, Internet of Things, and cloud-based solutions in tracking everything from the tooling, consumables, to the job itself as it winds through the factory floor or on the emergency floor. So in a medical hospital. So we're going to try to cover all those types of scenarios with Chip and Hosni. And again, please do have your cell phone handy to log in to Poll Everywhere, Poll EV / Jim DeVries 073. And as I said, this is the 23rd webinar. We have these webinars posted on the EIG website, consultingeig.com. And we appreciate you taking the time today, especially in light of all the restrictions that are still out there. And we hope that your family are healthy and safe. My name is Jim DeVries, founder and president of Enhanced International Group. EIG is a platform of 40 plus consulting companies and SaaS providers dedicated to empowering your organization's workforce by leveraging the EIG Partners Network. Our goal is to provide collective, collaborative, experienced thought leadership to enable organizations to deliver self-sustaining positive margin growth. The competitive advantage focusing on 90-day action plans. We thrive on 1 + 1 + 1 = infinity. We hope you find that the information that we provide is informative for you and your teams, and we welcome your questions and comments to support you in your efforts. Please, again, have your cell phone or open up another window for the Poll EV, Jim DeVries, DeVries 073, as was sent in the email. We organize along people, process, data, and technology. Next week, we'll have a webinar on new product introduction and rational risk taking. The following week, we'll go back to supply chain risk and resiliency and talk about maturity models. And we'll also go back to our AI, artificial intelligence webinar series on OCR. With that, I'd like to introduce two highly respected leaders in digital transformation, Hosni Adra and Chip Dreyer. Hosni, a few words.
Yes, hello everyone. Hosni, just quick background on myself. I'm an Ohio State grad with a master's degree in computer engineering and computer animation. Started out in finite element analysis, finite element simulations, and fluid flow analysis, and then transitioned to actually build the ProQuest library system production environment in the background that kind of controls all of the document flow and the creation of the actual material that's built into the ProQuest environment. Through that, I developed an image processing algorithm that actually was patented and eventually sold to Xerox at some point. From that, I tried to find a simulation environment to actually help me produce and generate a good representation of the flow we're doing. And at that time, we're talking the early 90s, there wasn't really any good simulation tools out there that were able to do that. So I decided with a couple of friends to start Create-A-Sauce and actually start building a new type of simulation system, which is, eventually got called SimCAD Pro. And our goal was to create something that is easy for people to use. It's got less programming, it's no coding environment or little coding environment, and it allows you to interface with a lot of different things. Now, back in the 90s, that was a big feat, as you can imagine. So we released our first product in February of 96. And from there, we kind of started expanding and adding to the feature list of SimCAD, from a pure manufacturing setting to adding healthcare support, logistics, and warehousing. And then we added automation and autonomous robots and so on as the industry evolved. So in SimCAD Pro, some of the key things that were included, for example, is the fact that you can change your model on the fly. You can interact with the simulation environment. You can have in a simulation environment that has a process mapping and a value stream mapping built in together as one tool. So that basically provided us a few, we were awarded a few patents on the technology, from on-the-fly simulations to tying RTLS to simulation environment to value stream mapping and so on. I've been involved in many industries. As I mentioned, that actually helped me develop a platform of technologies, things that are used in a high-mix manufacturing environment were able to be used in a healthcare setting or in a warehouse implementation. So we kind of evolved our tool set to be able to expand on all of these different products, to all of these different industries. And with that, I submitted and presented a lot of papers and IIE, Lean conferences, WinnerSim, simulation conferences, and so on. At this point, as a tool, I'm kind of driving SimCAD and our digital twin solution to connect it to real-time data systems, to live data streams, as you will see as we go forward. And I'll explain, I'll go through some of the experiences that I got as we're implementing those. Thanks, Jim.
Thanks, Hosni. Chip?
All right. Yeah, thanks, Jim. My name's Chip Dreyer. I'm the president of Wisers, and my charter is really to grow the business outside of Brazil, which it was where it was founded. Wisers started about 4 years ago in a relatively small town of Piracicaba in Brazil, from some friends of mine that I used to work with in my previous job at Kennametal. So I joined them to help them grow internationally. They've got a lot of very good traction in Brazil with close to 100 customers. Wisers manufactures smart technologies to help mainly smaller and medium-sized businesses enable Industry 4.0. Prior to Wisers, I worked with Kennametal and Greenleaf that are both in the manufacturing space, supplying tooling. And before that, I worked for GE Energy for 20 years, and that's where I met Jim a while back. I won't say how long ago. I don't want to embarrass us. I live in Pittsburgh, and I'm married with 3 children, 3 boys, 15, 13, and 11. They're all hockey players, so weekends are very full. And I really look forward to our discussion today on Industry 4.0 and the benefits of digitization. Jim?
Thanks, Chip. Thanks, Hosni. So just as a little bit of background of how everything fits together, we believe in this people, process, data, technology. It's when all 4 of these things come together that we're able to achieve Industry 4.0. So first, we need the right people, the good talent management, the right skills, and the right job in the company. Secondly, from a process perspective, we need to be able to leverage our tools from a Lean Six Sigma perspective, or whatever's in your toolbox. And thirdly, the most overlooked area is data. We need trustworthy data that's believable, that enables us to make these real-time decisions that we're looking to do. Most ERPs, as we know, are lagging. They're roll-up data, and they're really there from an accountability perspective versus making timely based decisions. So we know that time is money, and any delay in a decision is going to cost us. So last but not least is technology, and we're using a lot of technology here but we're using this technology to enable other technology. So it's not, there's no magic button as we often talk about. It does take the work of bringing together the people, process, and data to achieve that. What the nice thing about this technology you hear about today is it's going to help us bring that data to make it visible so that we can, our technology, our manufacturing, our operations, or our process flows in a medical environment, all these things can be accelerated through these digitization efforts, through the Creatisoft and Wiser's platforms. So we're really working to provide the frontline worker what do they need to do and when do they need to do it. We're giving them that instructions based on taking into account all those external sources of information, much beyond what you capture in a typical ERP or even in a SCADA system. So we're bringing that data together, and we're bringing together IoT data on top of that. So we're overlaying all this together to tell the story. So we'll be discussing how to increase the inputs or increase the outputs by reducing those inputs and inventory and ensuring that you have exactly what you need when you need it. Moreover, we're not trying to lean out the system so far that it's not resilient. We're bringing visibility. So as a supply chain risk and resiliency advocate, we're not going to make the processes less resilient. They'll be more resilient because we'll have believable data underneath. So with that, the agenda, we're going to discuss our roadmap to Industry 4.0, and then we're going to get into real-time cost of goods sold and inventory management. Chip will get into that, and then Hosni will get into unleashing the data-driven digital twin. And then he'll start with real-time prescriptive analytic decision-making. And then we'll talk about how do we move from a 30-day, 60 days, and 90 days into this. We feel that we're first of a kind at being able to achieve this much advancement on your manufacturing floor in the shortest amount of time. So with that, we want to start by talking about the 5 steps to improve your business. And we broke it out into organize, standardize, visualize, stabilize, and optimize. So we'll go through each one of those. First, we want to get our house in order. And, the 5 S's, sort and organize, a lot of the lean tools, basic tools will get you there. Then we need to standardize, again, keeping up with the 5 S's and standardized process. Then we need to visualize. And this is where Hazi just mentioned a few minutes ago, Creatisoft has a value stream electronically. So moving from a paper, wallpaper environment into digitization right away with the value stream and tracking flow is critical to help improve your business. And creating those data systems, collection systems that are integrating all the data from event-based data to continuous-based data into your system. So we need to be able to visualize that and believe that that data is real, validating that with our frontline workers. And then just overlooked step is stabilize. We often want to go visualize to optimize, but we really need to stabilize our processes first and drive stable operations. So stable operations is based on theory of constraints. You're only as strong as your weakest link. And so we need to make sure that we're not robbing Peter to pay Paul as we're trying to improve our processes. And that's what generally gets in front of us when we are, or gets in front of us or blocks us from going beyond this step. Most companies will get to visualize and the value is not seen because we're not taking that stabilize step. We often try to do visualize to optimize. And that's the panacea of being able to optimize at a moment's notice. With that, Chip will bring us through the next slide.
Okay, thanks, Jim. Yeah, we'll take a look at the same slide Jim just reviewed, but focus primarily on the first four elements for my section: organize, standardize, visualize, and stabilize. Hosni will come in later on and address the optimize piece. I believe as we go through this process, that if we introduce process data, pillar of the Industry 4.0, that we can make our changes stick. Also, what you find with the data is that you drive accountability. The end result is we'll make our businesses much more proactive and less reactive to what's going on in the environment. This is what I hope to show you in the next 10 minutes. I always like to use analogies, and for this one, I'll be using cleaning out a shed or a garage. When you look at the space initially, it's a mess. There doesn't seem to be any order. But things do get done. I mean, you can still park your car in there, and in the shed, you do have space to get some of the tasks done. And nobody really wants to get in there and deal with what might be living in there, or what are some of the items that are not adding value to your everyday life. But it is a necessary first step. And the same really goes for business. You have to go through and take stock of what you have, and the productivity as a result is considerable. So going with the first step, organize. You need to step back and understand what you have. This usually involves pulling everything out, touching every item, and then sorting them into typically 3 categories. These are the valuable items, which hopefully are most of the things you pull out of the shed. The next item are initially not valuable, but could be repurposed. And the third is, of course, the junk pile that you need to dispose of. The next step in the process is standardize. As you restore the items in the shed, each item will have its place, and you and others using the shed need to know where that is. The old tool that you found that you replaced as a backup will have a spot on that shelf. So repurchase of items that are hidden in the mess is one of the benefits of going through this, and it has significant paybacks. And once this is done, the shed's transformed and is much more usable. The next step is visualize. As you go through this process, you will invariably think of ways to use existing assets that you have to improve your current process. It might not be transformational, but it'll be positive change. The extra chop saw you found under the tarp could be used for an extra cutting process in your facility when the cutting station's overloaded. So you kind of get the idea. Nothing transformational, but things to help you improve the existing process and get you to understand what the entitlement of that process is. And the best news of all is it's typically done without spending money. You're just repurposing your existing assets. Stabilize is very important for the changes to last, and this one needs a lot of attention. Typically, once you get the shed cleared out of everything and has a spot, what happens, right? Normally, other users come and use items, don't return them to their assigned spot, and you find after a week or two, the shed is back to its normal unorderly self. This process didn't stabilize. You'll need to train your coworkers on the new process and introduce some new rules. This is where digitization can help in driving things. With labeled locations and discipline in the workforce, soon it becomes habit for the other users. With the data, there becomes accountability, which drives further cost reductions. This is where Wisers can really step in and help. Once the process is stable, we can look to optimize and or overhaul the process. This is where Hosni's system can really help out. I'll turn it back to Jim now for the polling question.
So the first polling question, and if you would join the polling at pollev.com/Jim DeVries 073. We appreciate it so that we can get your feedback on where you believe you are in your organization on your digital journey. So are you at the organize stage, standardize, visualize, stabilize, or optimize stage? Which stage best represents where your organization, if you're in a shop or you're in a whatever environment you are, that would be great if you could respond there. So we'll start showing the responses here. Well, look at that. A third. That's pretty funny. So very interesting. Any comments from Chip or Hosni on what you're seeing here?
No, it looks good. Yeah, I mean, yeah, I guess more or less what you'd expect. For the optimize, you'd wonder if, we're like comparing to the same perfect world, you might say, Jim.
Mm-hmm. Yeah, I mean, if you've gone through all this and you're in optimize, that's fantastic. And it's, can you maintain that over a period of time? So we had a few more people respond. Hopefully you're finding it all right to get into poev.com, Jim DeVries 073, that URL. And we'll just wait just a minute. We have 4 or 5 more polling questions. So if you fall behind, don't worry about it. And you missed this one, you can answer these questions at any time throughout the webinar. So with that, I think we'll just move to the next, but very interesting results. Thank you for participating.
Yeah, that's good. All right. Yeah, thanks, Jim. Yeah, another way to think about what we just discussed is the 5 S's. 5 S's are a lean term, and it's really defined as a methodology that results in workplace that is clean, uncluttered, safe, and well organized to help reduce waste and optimize productivity. And that's exactly what we were talking about with our shed analogy. In the next few slides, I'll introduce digital tools that can help look into places, generate data, and drive accountability. This will result in savings and cement the new process in place. We'll run through our shed cleaning example again, but inject our digital systems to highlight how this will help make the changes permanent. So starting with the upper left orange box is the sort. Going through all the items and eliminating the ones you don't need. Repurposing where you can items initially with no value to add value to the business. This is a necessary first step to get entitlement out of your existing process. Next is set in order. This is putting items in their assigned spot. The journey to Industry 4.0 can start here. Without much investment, you can build a digital twin in the Wiser system and label and assign items to a spot in the shop. Once it has a place, people know where to go to get it. In the Wiser systems, you have people sign in and to sign out items, and then they sign them back in when they replace them. And we could do this with open shelves, or if a company doesn't want to use the honor system, we do have smart lockers that we can pretty economically deploy, so the users can log in quickly, pull the item out of a secured locker, and then return it when they're done. Either way, data of usage of the product is generated with a timestamp by the operator. If the items are in a fixed location, this saves a tremendous amount of time. Half of most home projects are spent looking for tools because we have multiple users in the house, and the earlier process never stabilized. Many times this results in a trip to the hardware store to buy an item in the middle of your project that has gone missing. So talk about a productivity killer. It's a big cost and time matter, so we can't underestimate the importance of this step.
Yeah, Chip, and just to bring it up, there's always a run, right around lunchtime every day to go to the Home Depot and stop at McDonald's, right?
Yep. When the item is yes, at somebody's desk, right? So yeah, very costly. So the third step in our process is the shine. Now that everything's in place, you can take full inventory control with a product called the SpinWiser that is designed specifically for consumable. It'll track usage by operator, by project, by cost center. And I can highlight an example of this. I went to Lowe's recently and spent $70 on batteries for my kids' toys. And the batteries were all over the floor beforehand. I didn't know which ones were used, which ones weren't. I don't know if that's a familiar scenario. So I did invest in the batteries. I stuck them in the Spinwiser, and now the kids have to access this to pull them out. And the battery expenditures have dropped off dramatically. So you do get rid of a lot of waste in the system when you do track things with data, even in your own home. Step 4 of the process is standardize. You can take things farther by establishing new inventory needs based on your capabilities of tracking usage. So right now you have clear visibility into what tools, what items are used when, and how much and by who. So a logical next step is to leverage this data to shrink your inventory. So if you have minute by minute inventory levels, you can, instead of reordering once a month, you can reorder daily if you want. Any spikes in tool consumption will be highlighted immediately. So the data enables you to know your inventory by the minute. So we've had customers reduce inventory levels by 40% for consumables using our system, which is tremendous. And step 5 is most important, is the sustain. Our system with the data tracking really helps to keep items where you designate them. It also ensures that the operators follow the new process, especially if you use smart lockers. This data has driven accountability in the process, and we find adoption is very, very quick. Slightly painful initially, but the system is very quick and easy to learn. So we find that it gets adopted very, very quickly. Okay, flipping through going to the next slide. Now that you've gone through the 5 S's and you've laid a foundation, the digital journey doesn't need to stop. Right now, your business has a foundation for the pyramid. You can now track consumables and durables within your business with great accuracy and great data through the digital twin. And armed with this data, you'll find that all of a sudden you have new capabilities that you didn't think of. The payback for what you've done for the part A is amazing. We've seen over and over again that if you control tooling, you can get 10 to 20% reduction in tool spend. And it's not uncommon for a company to spend $100,000 per year on consumables. So that would be $15,000 in savings yearly with no change in the process. This isn't what Hazi's going to talk about. This is just controlling the tooling. Now, this doesn't mean that the operators on the shop floor are stealing tools and bringing them home for their shed. What it does mean is it's the accountability part, I believe, that if an operator is running a process and they're breaking drills, that they will stop, fix the process before they continue because they know drill usage is being monitored. So you're fixing the process as problems come up. And this is really what the accountability part gives you. The data is visible and it's out there for everybody to see. So this is really the low-hanging fruit of digitization and starts the journey. Once you have the information, it's a pretty easy step to move up to level B. You can use this information along with the preset stock levels that you would enter in to reorder items automatically based on safety stock levels. We touched on this earlier. With minute-by-minute inventory levels, you can finely tune these stock levels and help eliminate any stock outs that you have. So this real-time tracking is pretty amazing when you see it in practice. And it does eliminate a lot of backroom activity of tracking and reordering tools. The next step up the ladder with the data that the foundation that you've laid down is that we can step outside of the CNC machine and begin to look at OEE, which is overall equipment effectiveness. So this is a measure of how much your equipment on the shop floor is operating. So this is essentially tracking how often your equipment is being used and the reasons why it isn't running. The Wiser software can Pareto these and give you very targeted projects that you can use to improve output for your process. And the payback here is typically 10 percentage points. And depending on what machine it is in your process, it could be 10% increased output if it's on a critical path unit. And lastly, there are modules that we have developed that can help with plan expansion. And all this is for an existing process, not changing the process. So it just shows the power of Industry 4.0. So you can see how the journey can start with a simple first step in organizing and getting control of the consumables. All right, flipping over to the next slide, just to give you an idea of what this looks like and what it looks like in action. Below in the middle left, you see a factory schematic, and you'll see our consumable trackers called the Spinwiser in green. These are small units, and I'll describe in a little more detail later, but they're basically compact and they can sit right next to the machine. So it's secure storage out on the shop floor where the tools are used. And the size has been an advantage for us. And this not only saves tooling costs, but it cuts down on travel time for the operators needing to go to the tool crib. We quoted a job in Canada where the tool spend was very, very low, but we did, I think it was 50,000 a year or something like that. And, but we did look at how long the operator left the machine to go get tools. And it turned out to be 20 minutes a trip. And he usually did 3 trips a day. So this was an hour of productivity gotten back by just keeping the tooling next to the machine. And that payback was less than 4 months. In blue and orange, you can see the products, the other product called totems, which are, these are the items that create the digital twin for tracking larger items. So we can track everything in the tool crib, or we could do secure lockers out on the shop floor. And this will give you a plant-wide view and minute-by-minute usage of the consumables and the durables. And it will communicate seamlessly with the Spinwiser system. Now going over to the tablet on the right, it really all starts here in our secure cloud-based system. And it can be accessed by any smartphone or tablet by a user who has authorization. If you click once more, you'll see our totem. And this is the item that can track either securely or in open shelving, larger items. And for secure storage, we can build or repurpose lockers or employ our smart locks. And you can see an example of this in the lower right. Spinwiser machine is the one that you see here that sits next to the CNC machine and manages the consumables. It's got 5 doors and 75 compartments in a carousel that rotates inside the unit. And this is ideal for smaller, valuable items. And we do have experience operating other high-value items that customer wanted to get out of the tool crib. The benefits of the system are detailed reports that will streamline operations. The shop managers love this because they have the data at their fingertips. We can track tool usage by job, cost center, operator, product. And we can also configure it to auto reorder supplies based on safety stock levels that the customer can put in. So everything's real time and the data is visible and actionable. I'll turn it now back over to Jim for the polling question, and then Hosni will discuss the process optimization. Back to you, Jim.
Thanks, Chip. So the next question, again, if you haven't joined already, please join us, pollev.com/Jim DeVries 073. That's DEVRIES 073. So if you could respond to this question: how well does your business track tooling and consumable costs and material stockouts? So please go ahead and enter in. Very well, extremely well, so-so. So it sounds like at least one person here already has a similar system to track consumables. So we're looking for additional folks to respond. Chip, any comments on what you've seen in your dialogues on the floor and talking to folks?
Yeah, well, typically, Jim, like the customers that have adopted the system have absolutely loved it. And many of them were skeptical to begin with. But generally, we've seen in some cases, the first month, the customers will see like a 40% reduction in consumables using the Spinweiser system. And this isn't, this is getting rid of all the hidden parts that are in the machinist drawers and stuff like that. But it usually stabilizes to around 15%. So it's been seen a lot of success, not a lot of complaints once they get used to the new process. And the access to the machine is very, very quick. You can use QR code or simple 3-digit code to access, and then you have a PIN and the tools are right there. So we find typically that it goes from about a 20-minute time to get a new tool to about 30 seconds with the Spinweiser next to the machine. So it's been a good, it's been very, very well received so far.
And can you also assign the cost to the job better?
Yes. Yeah, you absolutely can. So that's a big feature that our designers are very much sticklers about. I had conversations with them this weekend after meetings that I had, was that they want to be able to track down to the job, the cost center. We could track down to the product, the operator, so there you can really slice and dice the data. And it requires you, if it's a job, just like a flow part that come through, the system's set up to accept a cost center and a cost center and a job number. So that visibility is all there.
Yeah, that's one of the biggest goals has always been, is the consumables is just, we use thumb rules generally, even today, in a lot of Lean Six Sigma shops. We don't want to track this because it's too much work. We don't think there's value in it, but there is value in uncovering and getting to the cost per manufactured item, which we would never be able to do without a system like that. So,
yeah, it even takes it to the next level. So let's say you buy a holder for the tool, and the life of the holder you think is 1,000 cycles right through the machine. It will allocate that portion of the holder life deterioration to the job as well if you wanted to. So it gets very, very sophisticated in how it breaks down the cost.
Well, thanks, Chip. This has been enlightening, and I hope everybody enjoyed this part of the webinar. We're now going to switch gears a bit and talk about the digital twin with Hosni. Hosni?
All right. So let's go through how you actually integrate and progress to a digital twin implementation. So one of the things that I'm going to mention here is that will apply to different industries. You can apply the same concepts to healthcare. You can apply them to warehousing. You can apply them to of course, manufacturing, which I'm going to use as the main example in this case. But for many organizations, you've got the 5 different steps that you have where you organize, standardize, visualize, stabilize, and optimize. And I'm kind of very intrigued by the answers that no one is in the standardized section and no one is in the stabilized section, which was pretty interesting. So from a simulation point of view, if you take the implementation of a digital twin, you start by doing a simulation implementation, then you expand it all the way to the full-blown digital twin. So as you're doing your organization and you're identifying what flows you have and how things actually progress and kind of document all that stuff from an organization point of view, you can start by building a process map and kind of visualize what the process maps are. You will have, parts flowing through, but it's purely to identify what those processes are and identify what is needed and what is not. You're going to realize that there are some processes that's been there just because historically they've been used and you don't need them anymore. So this is part of really organizing and identifying everything that is required and using these type of mapping and kind of pseudo visualization environment to show you how things are progressing. Now you take that information, then you turn it into some standards that you're going to use for individual parts that are being produced. whatever those parts are, they're going to flow through those standard process steps. You're going to have a standard QA processes, testing cycles, and so on that you're going to standardize on. And then you're going to see through a simulation environment how those standards are actually going to impact your flow. So that's when you go into, my failure rate. How is that going to impact my throughput? How can I modify the operation to actually improve the takt time of the operation and so on? So you kind of start to use simulation to analyze the operation, actually generate some key standards of where you need to be going forward. And then from that point, you would start to visualize the operation itself. And that's where really those dynamic value stream maps come in. We've seen a lot of companies that actually start the organization or the organizational step by starting with a static value stream map. You walk into a boardroom and it's got a ton of post-it notes everywhere. And that's great. But they're post-it notes that make sense until one of them falls off and goes out of sequence. So these are key things that we identify is first start with the process flow, then go into what we call a dynamic value stream. As you change your cycle times, as you change your process flows, your testing requirements, everything else, your value stream is going to change. The value stream is never a constant entity. That's kind of one of the things that we introduced as part of a simulation environment, that when you actually make those changes, you will see the new improvement and how the value stream will actually play out based on what you've done. So those OEE numbers that will come in, let's say by implementing the tooling system, how is that going to impact my operation? What's my OEE going to look like? What are my WIP levels are going to be? Do I implement the push? How do I change my Kanban side? All these could be analyzed at that point. Then once as the system evolves, it starts to go into the stabilization phase where things are starting to kind of follow a specific set of sequences, and you're kind of starting to get hold of the operation, and that's when you start turning that implementation that you have into a pure digital twin. And I will talk briefly about what I mean by a digital twin. Then you take that into the optimization phase. So now I have my digital twin. How can I leverage that technology to actually help me do better going forward? A digital twin is a good representation. It should be an exact replica of your operation itself. It's like a clone of your operation in a virtual environment. So as we go into the next slide, just want to talk about kind of what those different components, what those types of digital twins are, and kind of some misconceptions of what a digital twin is in the industry. It's just similar to what happens with Industry 4.0. You ask around and you get 50 different types of answers on what Industry 4.0 means. So by looking at a digital twin, the way we identify a digital twin is basically 4 different types. There's the visualization type, where you have very cool visuals. It shows you the plant, it shows you the warehouse, it shows you the ED implementation, every single location, every single machines, people moving. It looks great. It's very colorful, rendered to almost a real life type rendering, but that's all it is. It's just a visual. It just shows you what an operation could look like. So this is like an architectural rendition of a building before people walk into it. You would have people animated and walking through the plant, but that's all that it represents. It's just a visual. And the misconception that we see in the market is that people will look at the visuals and they will assume that there's a lot of meat behind those visuals, which is most of the case is not true. So this is kind of a very cautionary thing that we do. Even when we go into an implementation, we try to avoid showing visuals until there is actual representation of a plant in the background. and it's just not a representation of the visuals, because you can do these very quickly. You can create a great wow factor. Everybody loves it, especially, anyone who's, higher up the chain. They don't know all the details that's going in, and they will assume that your work is done. And then they will say, well, now how can I improve my operation? Well, guess what? You can't do any of that stuff. So as you go from there, you go into a randomized twin. A randomized digital twin allows you to, it has the constraints of the facility. It's got your changeovers, it's got your Kanban sizes, all the tools that you have within the operation, but it's purely working on randomization. So it's assuming, for example, that a machine is going to fail 50 times a day. It's going to assume that you're going to have a cycle time that varies between 1 and 15 minutes. That's great. That's going to give you a great insight on the operation itself, but to actually get true results out of it, you always have to interact with it. You have to go in and make changes to the data to recompute your distributions that you're actually putting into the randomization engine itself. Now, one key thing that we've seen in those environments is when you actually use a lot of random data, your model is so variable that you cannot really use it for effective analysis. You will have to run a lot of scenarios. You implement a Monte Carlo type simulations to actually see if your model is at least conforming, where you can ask its question and it's going to help you get to the solution that you need. So this is the kind of the iteration of where a lot of people think that a digital twin is. In reality, a digital twin, if it is a true representation of your data, of your plant, it needs to consume data the way your plant consumes data, and it needs to react to that data the way your plant reacts to that data. So at that point, it's going to use all of the constraints of what the machines are. It's going to use all of the constraints of your human resources, the manpower, your shifts, everything that actually drives the plant. And at the same time, it's going to consume data from your ERP, your SAP, for healthcare, for your EMR or a WMS environment. It's going to consume all that data, and it's going to show you what your plant is doing at this point in time. So if I open up the digital twin of my plant, I need to see in real time, this is my digital twin. This is the plant in real life today at this moment, and that's what it's doing. Then from that point, if I have a true current state of my plant, I will be able to produce a good predictive state going forward. So that's when your data-driven digital twin is a lot more constrained in the way it works. It has a lot more data to work with. It knows where it's starting from, and it knows how it's going to progress going forward to do the predictive analytics going into the future. And so what you tie into that data-driven twin is not just your ERP or your SAP data. You're going to have work orders that are going to come in. These are going to be anything that you're going to produce going forward. You're going to have data coming in from your PLCs on your machines saying this specific saw blade, for example, is getting used too much. And it's going to be, you're going to have to start going into the maintenance aspect of it. So that data now can be feeding into the tooling environment to say, this tool is being consumed faster than it normally is. And then that could feed into chip system where it will identify that the reorder sequence for that tooling now is going to happen faster than it normally does. It's going to look at your different product mix, especially where you have high mix operation. If you are building a car, amazingly enough, a car manufacturing is a lot of high mix, high volume type implementation. So they have a lot of different manufacturing steps or different parts that have to feed in. But from a true high mix that's outside of the automotive industry, that tooling requirement actually will change a lot as you go through. This is very similar to healthcare. in a healthcare setting, if you look at the representation from a healthcare to a manufacturing, healthcare is a high mix operation. You don't know who's going to walk in the door. You don't know what kind of problem they're going to have. You have some history of who could come in, for example, early spring, but everything is going to change as they go into the process. And a high mix operation is very similar to that. Now, a data-driven digital twin is going to be able to react to all these things very quickly. It's going to be able to learn from the historicals, and I will talk here in a second about how that historical data actually comes in.
So,
but the key to it is, sorry, Jim, go ahead.
Yeah, I just wanted to answer. There was a question that came in. I don't mean to interrupt, but we're coming up on the hour, and I want to make sure we answer this question from John. He said, and this is a question for Chip. I think it was on the Spinwiser. Is it only for small parts, and what's the largest form factor part that could be utilized in your system, Chip?
Oh,
sorry.
Okay. Yeah,
the answer that John had to go.
Yeah, sure. Yeah, the largest part it can hold is around 6 inches in length. That's the depth of the compartment, and the door is around 4 inches wide and like 2.5 inches tall. So it is limited by size. Now, if we do go with much larger parts, we could do the smart lockers, but it's kind of purposely designed for a machining environment, and a majority of your end mills, drills, turning inserts, and all of that would be able to fit in there.
Thanks, Chip. Sorry to interrupt, Cosney.
No,
I just want to make sure.
All right, no problem.
The hour. We'll probably end up going a little bit over 1 o'clock. I apologize, but I think we're in some very interesting topics. So I just want to answer. If there are any Q&As right now, please put them in the chat box or in the Q&A box, please, and we'll answer them as they come in while Hosni continues here. I don't mean to interrupt, but
no problem. Thanks, Jim.
For everybody. So go ahead, Hosni.
You can go ahead and so the one thing I want to mention on the learning digital twin is that as those digital twins are actually evolving within the operation, they have the ability to learn from the operation itself. So although you put in constraints going into it, as the system moves and runs in the background, it's actually learning all the details that are varying throughout the operation. Whether they are changeovers, whether they are machine downtime, the way people operate. So instead of going in and doing time studies all the time, that digital twin is actually giving you all that data and make it available to you. So we can jump into the Q&A, the polling questions now, if you want to just go ahead and.
Yeah, so for this polling question, this is a little bit more complicated than the previous polling. You need to use your up and down arrow on the left side of this as you see it on your screen to rank, let's say, the top 4. You can rank them all if you like. But what are the top things that you, from highest to lower, from what you want to get? When you think of digital twin, what benefits do you want to get out of it where you think you're going to see value right away? So very interesting that full-scale prescriptive is on top, which is you got to build to get to there. As we just discussed, it's an evolution. Maybe some more mature folks on the phone on this webinar that are already doing visuals.
That is great. That's awesome.
Go ahead, Hudson. you're
all right.
Any other comments?
That's actually good to see from an implementation point of view. I know scheduling is a hot topic. Amazingly enough, it is low on the scale in this case. Offline predictive analytics, I assume everyone who has done some type of simulation of some sort has done offline predictive. Online predictive and full-scale prescriptive is pretty interesting, and I'll actually address some of those on the next slide here as we go forward.
Thanks everyone for participating, and you can continue to participate on this. Very interesting to see. Okay, back to you, Haas.
All right, so let's just go through the path of a digital twin. This is a quick implementation, and the one thing I always tell people is, you know, always have to have a goal. You wouldn't start the marathon unless you really want to win and you want to finish. So make sure you have a goal up front, define the different steps that you need to go through, and then identify the type of digital twin that you need to achieve. So this is where your target really comes in. So if we just go in through the different goals that we have, if you're looking at only visualization, then you just basically pick a tool that's going to give you the visualization of the twin, and that's all you need. There is no point in going beyond that if your goal is not to implement more than the visuals themselves. Now, on the other side, if you're looking at a randomized twin that do the initial assessments and the implementation and kind of to identify what you need to do, then that's when you basically do operational analysis and you do your randomized twin to go through that. The majority of the people in this webinar are going to go through the third option, which is really going through expanding to IoT for Industry 4.0, going to full prescriptive analytics, going to full scheduling, and that's when you go into the data-driven digital twin. Remember, data-driven digital twin has the visuals. It does have the randomization aspect. It just takes you this next level up to allow you to do all the different things from a prescriptive and predictive analytics. So if we look at the different steps there to actually identify the plan, initially what you would do is you would just go in, you have to break the plant into sections. You kind of do it step by step. You don't just expand and say, I want to build one twin for the whole plant right away. The key to it is to actually plan your way around and do it in smaller segments to expand and improve on what you have done. Then from that point, you go into the learning phase of the digital twin. You connect it to the real-time data. You let it learn. And because the digital twin and the solution we actually provide has the optimization built into it, it actually allows you to do the prescriptive analytics very quickly. So let's say you have a work order that needs to be produced, and then for whatever reason, you're going to be delayed. So instead of having that order ready to be shipped on, tomorrow, it's predicting that you're going to get it done and it's going to ship on Friday. That's not feasible for the customers. So the system automatically figures out a new order sequence that will have to go in so that order comes in tomorrow and is ready to ship tomorrow. At the same time, it'll send that data back into your SAP system to say this is the shuffling that needs to be required in order to get that order out. And it's all hands off. You really do not have to interact with it to tell it that you need to make that change. There's a level of maturity within the company that you have to get to before you kind of create all this hands-off interaction. So a lot of companies actually, what they would do is they will get notifications at this point to say there is an issue, and these are the 2 or 3 different steps that you actually get it, will be able to resolve it and move the target date closer to when you need it to be. And then at that point, you can pick the one that you want, and it pushes the data into SAP or your ERP or EMR, and then it just progresses forward from that point. You go to the second. So this is kind of the system in general. If you look at it, we've got the data-driven digital twin running in the background. There's actually multiple multiple iterations of that digital twin running constantly in order to support the predictive and prescriptive analytics going forward. All the data connectivity are going through a standardized interface to go into that interface with the digital twin itself. And all of these connections are bidirectional connections. So you can actually feed data in and pull data out. Then you have all of the information that comes in from your location system. So a lot of times your WMS or your ERP system has enough data, but that's not all the data that you need. There will be some barcoding that is done on the side. You might have an RFID system that's actually tracking different people or different material handlers or things that are running within the operation. You might have robots feeding all these things from a location metrics. So all that data will come in to actually generate the true state of what you're doing. This is the same for an EMR or for a hospital settings. You have tracking data of every single person that's within the hospital, and all that's telling you is if somebody is in the room or not. If you don't use that data to something meaningful, then it's just data sitting out there. There's one environment where I walked in, and they had, more screens in the manufacturing floors than they have machinery. Every single metric that you can imagine of the plant was on those dashboards. And I looked at the information there, and I said, how current is that data that you're displaying? And then they said, it's 2 weeks old. And if you're looking at 2 weeks old data, I question how important that data is to show it to the floor people if they're only looking at something that happened in the past, not what they're doing now. So just keep that in mind as you're looking at those dashboards and displaying them. So the next thing that we're connecting to it is the Wiser system, where you can actually tie in the tooling implementation and kind of adjust what the tool lifecycle is based on consumption. At the same time, we're tying in biometrics into it, where the actual motion of the person is going to impact the fatigue factor that will affect your operation going forward. So if I do a repetitive motion for 2 hours in a row, then I might need to take a break sooner and keep my efficiency higher. So you'll be able to track all these things and how they vary all in one single implementation, one single environment. And that's really the goal of what we're trying to do in this case. You can go to the next slide. So, from a global settings there, you'll see the actual digital twin implementation that's built on the SimCAD Pro technology. And that's connecting to whether it is user interfaces and somebody injecting different conditions to see offline what would happen to the system, or data that's driven from a real-time event that has occurred, or if I want to just replay what happened yesterday. There was an issue yesterday on the plant. I didn't have time. It wasn't that critical, but I really want to address it. So I can actually rewind the tape and replay that event. I can see what happens. I've got all my data already collected. I don't have to figure out where's my time study for that event. It doesn't exist. There was no one there to take a time study. So in that case, I can actually rewind the tape. I can look at that event, figure out exactly what happened, and offline figure out a path forward. At the same time, I can have it do predictive and prescriptive going forward into the operation automatically within the system itself. As I said, value stream mapping is an output of your process and your standardization that you have done. So all that is auto-computed. You change your constraint, your digital twin updates based on the constraints on the floor. Your value stream map has changed already. And then you can see how it is progressing through time and how it is varying through time. That applies to many different aspects of an organization, not just on the manufacturing side. Warehousing has a lot of these. They might not use value stream mapping, but spaghetti diagrams, heat maps are another thing that they use. Congestion analysis, that's another thing that plays into healthcare. How is congestion and bed allocation actually play out into all these things? So all these are factors that will play out. And that's just an example of what a digital twin visuals may look like. This is just a sample of kind of the representation. The internet connection is slightly slow, so you might see it a bit, there might be some lag in the representation, but each machine and each value, each parameter that is actually being tracked is tracked by person, by machine, by part, and it's made available through either offline dashboards. You can dial into the system, actually have a live view of the plant. If you want to go to the next level up, you can put virtual reality glasses and actually go down and walk the plant. They're all different parameters and different things that you can set up. A lot of manufacturing goes through discrete and continuous type simulations or implementations. You get bottles that need to be filled and then packed, while the filling environment is totally separate than your discrete event in bottle system. So you need to tie all these things together in order to get a better representation of what needs to be done. Now, that digital twin is going to allow you to do scheduling. That's kind of almost a byproduct of any digital twin, is if you have it data-driven, then it's going to give you a scheduling implementation that you can use going forward. It's always going to allow you to identify the best way to implement to build out the widgets so that you can get them out the door as soon as you can. Organize, identify your WIP levels. What should my WIP levels be? How do they vary? All that data will come out of that digital twin based on what's happening in the plant. So all these are kind of different variations that you can set up using our digital twin implementation using SimCAD and SimTrack systems.
So that's fantastic. So we have our last ranking question, and it looks like some folks have already answered. So thank you so much for going ahead and doing that. Very helpful. So these are the top concerns that you have in deploying a digital twin. So number one is cost implementation versus ROI, integration with other systems, readiness, for digital transformation. Those are certainly my top three that I've encountered in my experiences. And then data accessibility and availability, IT pushback, and then towards the end, it's about people and production disruptions when installing the system. So thank you everyone for responding. Very helpful. With that, I think we're gonna close it up here. We're 10 minutes over, so thank you for hanging on, everyone. I really appreciate it. I know Hosni and Chip, you also. Just as a recap, Wisers really helps us out on the tooling end and bringing that visibility to inventory. And Creatosoft is really the data engine to get us to that data-driven digital twin that we just shared. So very powerful combination. We feel it's first of the kind. There's not a lot of folks doing this. Maybe you can share your experiences otherwise if you have other experiences. But this to get this up in 90 days in a location is what our goal is. Again, readying yourself for the digital transformation stage 1 through 3 that we talked about, and then getting us to realize that it's getting through stage 3, stage 4, crossing that gap, whether it's availability or it's OEE. How do you drive that improvement in your organization? And it all comes down to what I've seen is getting good, clean data that's believable, that you can make database decisions, and using the IoT that's now available, and a algorithm that can combine discrete and continuous data together to tell the story are very powerful aspects of the Creatosoft system. So some real big advantages in what we provide in order to get everyone up to that optimized stage that we discussed. Again, we've laid it out into 3 months, just to 12 weeks. Again, the value stream maps, the 5 S's that we covered early on. Weeks 2 through 4 is integrating it into your systems, both the Wisers and the SimTrack systems into your daily flow, and visualize it, having a visual value stream map, and having that data start feeding back in the implementation stage for the pilot area that you're focusing on, and then building upon what we've learned there to integrate and then optimize. And generally it takes in the order of You may have 3 or 4 of these implementations across your different product lines. So in 12 to 18 months, you can be fully digitized and working to stabilize so you can optimize your operations. And with that, the takeaways for today are, digital workflow starts with process visibility, providing that COGS and inventory management visibility we feel is fairly new, and the workflow meaningful simulations that Hosni went through, the different types of simulation and the value of getting to that data-driven digital twin so that you can have prescriptive process control. With that, are there any closing comments from Hosni or Chip before we wrap up?
No, great session, Jim. Thanks for organizing.
Thank you, everyone.
Thanks, everyone, for hanging on. Appreciate it. I know we went quite over, but we found it to be valuable. We will have this posted on EIG website by the end of the week, and send out the slides to all of you for participating. Thanks so much for participating in the polling. It's very, very helpful to get your feedback. And there is one last question. If you're more comfortable about deploying a digital twin, feel free to comment on that. That'd be wonderful. And then just to let you know, next week we'll be having more webinars on in different areas. The webinar that we'll have next is more of a demo where you'll be actually able to touch the digital twin and the Wiser system. And then April 27th will be a use case where we will show you what we're doing with a client today, and we'll share that case study with you. So again, we have our upcoming webinar series on supply chain risk and resiliency, new product introduction and development, and artificial intelligence, which is our next webinar. Again, thank you so much for joining. We really appreciate it.